So we're going to talk about set notation today, and it's all about probability. So let's just get some definitions firstly. Firstly, we've got the word outcome. Now outcome, if I did a random experiment and roll that dice 100 times, that's an experiment, and the things that can happen are the outcomes. So I roll it 100 times, there is a possible outcome, there's another possible outcome, and of course there are 6 possible outcomes on that dice. I got that dice out of a game called Boganology, by the way, in case you were curious. Now, so that's an outcome, so it's a possible, what's a word that I'm looking for, a synonym, a possible result in a random experiment. Alright, so that's an outcome. So let's get these words into our vocabulary. Sample space. Well, sample space is the bunch of different results that can possibly happen, the bunch of outcomes, and putting them into a set. So it's the set of outcomes. That was very neat. For the experiment. And then we've got this third term, an event, and an event is the word that I'm looking for is a set of one or more outcomes. To give you an idea about, that looks a little bit just like a definition that I'm, might be trying to just sneakily stick in there and hope that you copy it down but don't think about it too much. What is an event? Well, an example would be, in that experiment, I might just choose, instead of 100 rolls, I might just choose an experiment of 1 roll. That's an event. So 1 roll of the dice is an event, and then I might roll it a second time. There's a second event. So on event 1, I might end up getting an answer of 5, but then on the second event, I roll it again and I get an answer of 2. And so events are just the happenings that produce outcomes. That's what an event is. Well, let's see if we can put legs on all of this, and let's go to an actual question about set notation, or just a bit of a show about it. Now, there was a mathematician maybe a couple of 100 years ago called Venn, and he came up with the idea of a Venn diagram. You've possibly heard of it already. Draw a Venn diagram of the integers from 1 to 10 if set A, so here's the way to draw a set, okay, you actually put some squiggly brackets, put your orderly numbers inside there and give it a name, so that's set A, there's set B. Now, you'll notice not all the numbers from 1 to 10 are in there. Let's see how this transpires. So here's the answer. I draw a box. All of the numbers 1 to 10 are going to have to end up in that box. Now, set A. There it is. Set B. There it is. And I've intentionally put some overlap because I notice that 1 is in both sets. I notice that 5 is in both sets. And I notice that 9 is in both sets. So that has to go in the overlap. Well, what's left over? We've got a 2 and a 6, and now you can see set A is now complete. And then we've got, in set B, we've got a 3 and a 7. But of course, what you notice at that point is there's only 7 numbers altogether, but we haven't filled out the remaining numbers. So what's missing? Well, there's a 4 missing, there's a 8 missing, and there's a 10 missing. So they have to sort of go out in the void outside of the 2 sets. Now, a couple of last things to notice is, if I was going to talk about this symbol here, A intersection B, well, that's just talking about the set of numbers that ended up in the intersection. So that would be 1, so it's like a new set, 1, 5, 9. And then I've got the set A union B, which means, so that kind of means what's in A and B for the first one. but this one is, sorry, that one's, yeah, that's right, A and B, but this one's what's in A or B. Well, what's in A or B, in total, we've got a 1, 2, 3, 5, 6, 7, and a 9. 1, 2, 3, 5, 6, 7, and a 9. So there's two things. Probably you've seen that one before when we've done domain and range, but that one's a bit of a new one. So there it is. So there's a bit of a look at set notation.